Since logarithms are essentially exponents, they follow the same rules that we had for exponents. Let's look at the product rule. You'll recall with exponents we are supposed to add the exponents. Here, when you see a product of a logarithm, you will add the logarithms. So the logarithm of a product is equal to the sum of the logarithms. To simplify, I would take log 100 and add log x. Now log 100 will simplify to 2. So my final answer here is 2 plus log x. You can write it like that, or you can include a parenthesis around the x. Next is the quotient rule. With the quotient rule for exponents, we know we're supposed to subtract exponents. The same is true with logarithms quotient rule. When you see the logarithm of a quotient, you can simply expand it by subtracting the two logarithms. We say the logarithm of a quotient is the difference of the logarithms, because we subtract. In this case, I would say log base 8 of 23 subtract log base 8 of x. Now, in the previous problem, I could simplify because it was a common log and it worked out to be a nice integer answer. But log base 8 of 23 would simply give me a fraction that I have to round off, so I'm going to leave it like this. This would be my final answer for this example. Here is another quotient. If I write this using the quotient rule, I'd have natural log of e to the 5th subtract natural log of 11. Now, if you recall the inverse property, that allows us to cancel out that natural log of e because they both have the same base, leaving just 5 minus natural log 11 as my final answer. Again, if you prefer, you can put parentheses around that value 11. The power rule for exponents is where we would multiply two exponents, and the power rule for logarithms is where we multiply as well. However, the item that you multiply would be the exponent inside the log. It will be brought down in front and multiplied times that log. So the logarithm of a number with an exponent is the product, since we multiply, that's what we call it, of the exponent and the logarithm. So here's how that would work. We would bring the exponent down in front, and we would have 9 times the log base 6 of 3. Now, the base 6 log of 3 cannot be simplified to give us a nice integer or fractional answer, so we would leave that as the final answer. In this second example, when the exponent comes down in front, I have 2 times log of x plus 4. Again, this one will not simplify, so I just go ahead and keep that as my final answer. Now, these logarithmic properties or rules can be used in the opposite direction. You could actually condense multiple logs using these rules. For instance, in example A here, it says write it as a single logarithm. We need to remember that the sum of the logs means that we are using the product rule. So that means I can take these two and just write the log once, and then I would have 25 times 4. Now that would simplify as log 100, and that would simplify to be 2. The same is true in example B. I see I have a subtraction. A subtraction is called the difference. A difference of logs means to use the quotient rule. So I can rewrite this as log 7x plus 6 over x. Now this one will not simplify, so I would leave that quantity as my answer.